Now first we will see variable voltage, constant frequency control. Okay, frequency is constant, but we will vary the amplitude of the supply voltage. We can achieve this variable voltage, constant frequency by using AC voltage regulators, nothing but AC voltage controllers. So transformers also we can use, but rarely. Thyristor voltage controller, now very popular for variable voltage, constant frequency control. 2 thyristors in anti-parallel for in each phase. Motor can be either in star connection or delta connection. Voltage control can be obtained by varying the firing angle, and only operations first quadrant and third quadrant. First quadrant means A, B, C phase sequence. If you interchange any two lines for 3-phase induction motor, it goes to quadrant 3, reverse speed, quadrant 3 operation. And this method also used for soft start of the motors. Now, how we can achieve this variable voltage method for speed control means, you see here, voltage can be reduced from rated Vs, nothing but there is a limit. For supply voltage, you can vary from 0 to rated value, not above the rated value. From torque equation, torque developed by the machine directly proportional to the square of the supply voltage. If voltage decreases, torque and speed also reduces. If terminal voltage is reduced by K times the supply voltage, nothing but Vs equal to K times Vs, torque can be calculated from this. Here K times Vs, you can use this one. But K here always less than or equal to 1, not greater than 1. Here you can see speed torque characteristics. This is torque per unit, this is speed per unit value, speed per unit value. Here 1 means synchronous speed, here 1 means maximum torque, here 1 means rated supply voltage. Okay, this is the speed torque characteristic for rated supply voltage, and this is the speed torque characteristic for 75% of the rated supply voltage, and this is the speed torque characteristics for 50% of supply voltage, and this is the speed torque characteristics for 25% of the supply voltage. This one is load characteristic, load torque, okay, which is directly proportional to the VR K omega R square. See here, for different characteristics, load torque, speed torque characteristics, different operating points we can get. See here, if you want to operate at this speed, you can select this operating point so that maximum supply voltage you can give. If you want to operate at this speed, you can select this operating point and you can give only 75% of the supply voltage. If you want to operate motor at this speed, you can select this operating point so that 50% of supply voltage only you can apply, so that power you can save. But see here, practical speed range is only this one is. Here also operating point, you can theoretically we can say this one, but practically not possible to get this speed to achieve this operating point. Okay, see here, variable voltage constant frequency is suitable for applications where torque demand reduces with speed. You see here, torque demand reducing with speed. As speed reducing, torque demand also reducing. This type of characteristics we can get only fan and pump drives case. Okay, torque directly proportional to the rotor speed square of the motor speed, and it is suitable for high slip, high rotor resistance type motors where high rotor copper losses, low efficiency takes place, and get appreciable speed range. Speed range is this one. Now disadvantages: limited speed range, yes, when applied to the class B low slip motors, and excessive stator current at low speeds, nothing but which gives high copper losses, and distorted phase current in a machine and line. Okay, nothing but harmonics will be introduced into the supply voltage, so that poor line power factor supply power factor is very poor. Because harmonics will be introduced into the supply, so that neighbors will affect severely. Hence, this method suitable only low power appliance type motors where efficiency is not important, nothing but small fan and pump drives case you can use variable voltage, constant frequency, speed control method.